This is part one of a three-part series of videos that are designed for people who've already done some introductory tidyverse, data cleaning and visualization exercises, but you're ready to start putting it all together and perhaps seeing some other examples of how to tackle your data. So this is going to walk you right through the whole process from start to finish. You should have downloaded from my website a zip file called building permits. Put that in a folder where you can find it, and it helps if there's not other things in that folder as well. And then unzip it. So I'm going to extract here. So what's going to happen is it's going to create a new folder called building permits, and within that folder you'll find a data file and an RMD file, which is our script in R. Stored inside that folder. And so just leave it like this with this building permits folder, and we will access it through R. So go ahead and open RStudio, and we're going to create a project in that same folder where that building permits data is. So go to the File menu and choose New Project. And since we already have that folder created, we're going to say Existing Directory, and then browse to that directory. Here's mine, building permits. And you just simply choose this open button and then say create project. So now in the lower right corner, you will see the project file you just created, and it has the same name as the folder. And then there's that data file and the RMD file that were in that folder. So this is now what is known as your working directory for this particular project. And R will recognize this directory if you tell it to try to bring in some data or you tell it to export something. It will put it in this folder unless you specify otherwise. So let's go ahead and open Permits Notebook in the lower right corner. You can just double click on it and open it up, and it'll open in this window. This is what's called a notebook file in R. If you go to File, New File, you'll see all the different kinds of files that RStudio can open and manage. The main ones for working with R code are Script, Notebook, and Markdown. Markdown allows you to make pretty fancy HTML pages with your output and hide your code while you do it. Our notebook is very similar, and it will automatically make an HTML file for you. It doesn't have as many of the bells and whistles as you will find with Markdown. I find it's a pretty handy way to work, but your code and your output from your code are in line with each other, and you can see it all in one place. A script file, your output from your code is not in line with your code. It comes out in a console in a separate window, and it's a little bit harder to do things like ggplot or have it display a table of information right in your screen. So I like to use either notebooks or markdowns. Today we're going to use notebook. Up at the top is a YAML header. That's YAML. You can Google that for other things, how you can fancy this up if you like. And here I've made a list of things that we want to learn. And let me point out first that you'll see that there's these white parts of your code page and then the gray parts. The gray parts are code chunks, and that's where we write our code. The white parts are areas of your HTML page that you can populate. So by putting a hashtag and a space, this is going to become a kind of the equivalent of a headline on my HTML page. And then these are just going to be a list of bulleted text. And notice I put an HTML break code at the end of each line to ensure they end up on their own line on my HTML page. So, throughout your page you can insert, and you'll see that I've done that with little headers along the way. And that will show up on the HTML page you make eventually. That's where it becomes most important. And then your R code is going to start with these 3 backslashes and the R inside the French brackets, and it ends with 3 more backslashes at the end. We'll use this insert button at the top to insert a new code chunk wherever needed. we're going to use 4 different packages today. Well, Tidyverse is a collection of packages, so it's more than just 4. But these are the ones that you should have installed. If you don't have them already installed, uncomment this code on line 17 and run each of the packages that you need. So for example, if you're missing janitor, change that right there and run this line of code. Pause the video, run the line of code and come back. When you're finished, make sure you comment that out so that if you somehow rerun this chunk of code, and you will in part 2 and part 3, you don't want it to reinstall again. It'll first of all take a lot of time, and you don't want to write it again. So once you're sure you have all them loaded, installed, then each time you run R, you need to turn on the libraries that you want to use for this particular script or notebook file. And you do that with this code. I refer to it as loading the libraries, and we'll run that. Now there's a bunch of different ways to run code within a code chunk. Notice that I only wanted to run this little bit, not all these other things that are in the code chunk. So you can highlight this and you can go to run and choose run selected lines. Also on your keyboard, you can do, on a Windows keyboard, you can do Control Enter when you have this highlighted. On a Mac, it should be Command Enter. You could also run a single line of code by having your cursor on that line of code and you hit Control Enter and it'll just run that one line of code. You may have noticed it showed a little green thing here for a second when I ran that. Now if you want to run a whole chunk of code, there's a little button over here that we'll do that in the next one, run current chunk. Or there's ways in this run button to say run current chunk, run next chunk, run all the chunks. There's a bunch of options there. So we've loaded our libraries. Let's import our data. This is using read CSV function from the readr package in Tidyverse. And all we need to tell it is the name of the data file. Because our data file is in our working directory, we don't need to give it a path or anything different. It is case sensitive, however, so the name of this file needs to exactly match the name of the file, and that's where it helps being able to see your name of the file in the lower right corner. And you also need to have the extension on there as well. Sometimes data files need a little more love and attention, bringing them in. And if you look up the, you can do question mark read CSV to pull up the HTML page that gives you all the syntax and the different options you can use within read CSV. Here, it's right here. You can skip rows, you can trim leading and trailing white space, you can tell it, this call types will tell it how to set things as date or numeric, or make sure some, like a zip code gets stored as character. So you can refer to that for directions on how to do that. This one is pretty simple, so we don't need to do it. What we're going to do is load this data into a new data frame that we're calling permits. And again, we're using an assignment operator here. My website has keyboard shortcut notes for both Macs and Windows on how to do this assignment operator, and also the pipe, which is used in Tidyverse to connect operations. In this case, we're doing an import, and then we're also going to use the clean names function from the janitor package to clean the column names in the data. R does not like, well, it's case sensitive, first of all, so writing code is a lot easier if all your column names are in lowercase, and that's what clean names will do. And then R does not like special characters, spaces in your column names that start with numbers, and clean names will fix all of that without you having to even blink. I tack it on to every import automatically, even if I think the data is clean. So I'm going to go ahead and run this line of code. I'll say run selected lines, and it's going to put a file up in my environment in the upper right corner. And then it's also going to show me down here that it brought this in and it's showing me the column names. And notice you can see the column names are in uppercase right here. That is indicating how they were originally. If we open our file, you'll see that they are now lowercase and all cleaned up by clean names. Another thing you can do is you can use str in the name of your data frame to load a list of the columns. So here you can see CO code, it's stored as character, and then it's showing you some of the examples. That's a county code. And you can see here's the city name, CTU name is stored as character. And then here's some examples from the top of the data. Here's where you'd want to check to make sure something like a year column actually came in as a number so that you can treat it as a number in your analysis. You'd also want to watch out for dates and date time fields. Zip codes, you'd want to make sure they didn't lose their leading zero. So those would be stored as character. But this is a way for you to check and see what R did on the import. Okay, so everything's looking good. So let's talk about this data for a minute. This is building permit data from residential building permit data for the 7-county metro area in the Twin Cities. If we look at the data, it's showing us for each city in each year, going all the way back to 1970, it's saying how many duplexes, how many multifamily units, how many single-family detached units, how many townhomes were built in that year. And notice that it has a row for each of these housing types, even if there were none in that particular year. So, and this goes all the way through 2019. We know what part of the metro they're in. We're not going to use that column today. And this quantity indicates how many units in total were built. So let's explore our data a little bit with some basic DPlayer code from Tidyverse. A quick refresher on DPlayer, you always start with the name of your data frame and then a pipe. Remember, we're connecting operations. And we're saying use the permits data frame, group by the year, and then summarize is how you do some math on how many records there are per year in this case. So this function n open parens close parens is R's way, how you tell R, I want to count records. And this number of records is my label that I am giving to that new column that it's going to create. Notice it says number of records, and I even spelled it wrong, so you can see that totally my choice. It is not a piece of code. It's just what I've given this label. You can run this without a label, and it'll just put the n, open parens, close parens, at the top of that column. I highly recommend putting something in there because you're going to see later we're going to be able to reference that column in future operations. We can add a pipe and do something else after it. And some like a range, you might need to, you would need to refer back to this column. In fact, we can do that right here. We can say a range descending by the column called count so that we can see which year has the most. In this case, it's going to be the most records. It's not actually the most housing units. We're just counting records. So you can see in these last few years, there's more records than there were in the first few years. Not sure why that is, but that is something to understand. Okay, so I'm going to clear this output. If you don't want to keep it here, you can clear it with this X. Now let's look at a couple other things. And notice here I'm going to indent my data. If you go to the end of the pipe and then hit enter, it'll indent the next rows, and it makes for a little bit cleaner reading of your data. So up here, remember we were counting the rows in our data, but in this case, if we want to count how many housing units were built each year, we need to summarize that quantity field. Remember, it has that column that says how many actual units were built. So we need to use a sum function on the column called quantity, and that's what this is doing. And again, here I'm just giving this column a name. There we go. Total units built, and there's too many rows for it to display, so you can toggle through and get all the way to 2019. Okay. What cities does this include? Let's take a, and here again, I'm just counting the rows because we're going to get an idea of what's in our data and do we have any dirty data here. So, ooh, what's this? We have 2 rows for the city of Blaine. If we keep looking through, 2 rows for Chanhassen, 2 rows for Hastings. There's a bunch of them like that in here. Here, 2 rows for White Bear Lake. This is because this data is set up to identify what units were built in each city, in each county. And cities like White Bear Lake and Hastings and Blaine actually cross county boundaries. Part of the city is located in Ramsey County, part of it's located in Washington County. But for our analysis purposes, maybe we want to summarize it up so it's just White Bear Lake total and not separated by what county it's in. So to do that, we'd need to clean up this city name column and collapse them. So we know that things that, let's go back to Blaine here. These records that start with the word Blaine, we want to collapse them together. And the records that start with Hastings, where was Hastings? Hastings, we want to collapse them together. So we could use, from the stringer package, there's a function called strstarts. And that means let's look in this column, and if it starts with a certain value, let's bring it back. So here is an example of how this works. I'm using it in a filter, and I'm saying pull from the permits table, filter it to any records where the column called CTU name begins with White Bear. And then I'm just telling it, group it by that name and count up how many records we have. And you can see that what we're getting is White Bear Lake and White Bear Township, which are different things. So clearly our string start here needs to be a little more detailed, White Bear Lake in this case, right? As we saw earlier, our Blaine example will probably work just fine. But it's a good idea to test your examples like this before you actually apply them to some data cleaning. So I've done that with all the other ones and figured out what we need to do. And this big, scary chunk of code here is going to do that for us. So let's break it down. We're telling it, make a new data frame, and we're going to call it permits. So essentially, we're writing over our existing data frame called permits. And then we're going to, and there's the assignment operator. And then we're going to tell it, take everything that's already in permits. That's what this version of permits means. And then the pipe means now we're going to add on to that. And in this case, we're going to add a new column using mutate, which is a function in the DPlayer package. And with mutate, what you do is you say, here's the name of the new column I want to create. And in this case, I'm saying it's city new. And then you put an equal sign. And then after that, you could put almost anything in there. You could just, city new equals 1, and every record would get a number 1, for example. You could transfer exactly the content from another column straight over to this column. The options are endless. You can do math, you can all kinds of things. In this case, we kind of have an if situation. If this is true, do this. If that is true, do that. And so we're going to use what's called a case when statement that is also part of DPlayer. So we've got this, remember the string starts, we've got that baked in here. And that is baked into the part of the case when statement that is essentially the criteria. This is where you tell it what to look for. So what it's saying is case when CTU name starts with Chanhassen. And notice then there's a little tilde in here. I'll put a space in here to make it easier to see. That means set the new column to Chanhassen. And this is what I want the new column to say anytime it finds a record that starts with Chanhassen. And so then you put a comma at the end of that one, and then you can continue to put as many case when statements in here as you want. So now the next line is gonna look for ones that start with Blaine, and then it's gonna look for Hastings, and on down the line. And when we get to the end, what you have to do is give it something to do for any record that did not meet any of those prior criteria. And of course, that's going to be a lot because we only cleaned up, what, 8 or so of the cities out of there's at least 104. I think it's more than that in this data set. So what you do is you write the word true and then a tilde, and then you tell it what to do with the rest of them. And in this case, I just want to transfer what's in CTU new, the original name, just transfer that over to the new column. And remember, it's just a good idea to always clean up your data in a new column. Don't overwrite your old data. So that's what we're doing here. We're just making a whole new column that has the city name all cleaned up the way we want it. So I'm going to go ahead and run this, run selected lines. And you'll see it does nothing down here, but if we open permits, we're going to see a brand new column over on the right with city new all cleaned up. Okay, so now let's put that new city name to use. Let's group by that new city name and count how many units were built. So we're going to use that sum again. And then we'll add a couple things on here. Let's filter it down to just 2019, which is the most recent year in this data set. And then we'll order it by the city name. And there we go. So now we can quickly take a peek and see if we only have one record for Blaine. If we go to the end, we can find there's White Bear Lake. There's White Bear Township, but we only have one record for White Bear Lake. So yay, it worked. We're good to go. So we're going to end part 1 here. What you should do is save this file. And right now you have a project open, but go ahead and choose Close Project. And then we will start anew with the second session. So go ahead and say Close Project. And I will see you in part 2.